Welcome back. Okay, today I want to talk about the first derivative test. We have talked about derivatives a lot and used them quite a bit, but we can actually use them to test information that will tell us about the graph of a function without actually just graphing it in our calculator. So I've written out the first derivative test here. Let c be a critical number of a function f that's continuous on an open interval. If f is differentiable on the interval, except possibly at c, then f of c can be classified as follows. If the derivative changes from negative to positive at c, then c is a relative minimum. If the derivative changes from positive to negative, then f of c is a relative maximum. If f of c, f prime of x does not change sign at c, then it's neither a relative minimum nor a relative maximum. Okay, what does this all mean? Well, let's go through an example and then you'll actually see this in action. All right, so we're asked to determine the intervals where the graph is increasing, decreasing, and find any relative maximum or minimum. Okay, so we have f of x is equal to x to the fourth minus 8x squared plus 1. We're going to actually apply the first derivative test. So the first derivative test means that first we find our first derivative. So the derivative here is going to be 4x cubed minus 16x, which is equal to 4x times x squared minus 4. So we have 4x, I've got x minus 2, x plus 2. And so if I set this equal to 0, which is what I need to do, I should have probably done that quite a bit earlier, set this equal to 0, x can be equal to 0, 2, or negative 2. All right, so 0, 2, and negative 2, these are our critical points. These are critical numbers that we're going to actually be testing. And when I do the first derivative test, I test it like this. Looks like it's crooked, but okay. So first, I kind of draw a little number line here. And I'm going to draw 0, negative 2, and 2. And then in between these points, I'm going to actually test points. So I like to write my test values up here. So I'll probably test like negative 3, negative 1, 1, and 3. And then all I do is substitute these in for f prime of 1. So not f prime of 1, but f prime of x. So f prime of negative 3 is going to be equal, negative 12 plus, or whatever, something, 16 times 3. It's going to be positive, maybe? I feel like I did not do that right. Negative, so 4 times, bust out your calculator when in doubt, negative 3 cubed, right? Minus 16 times negative 3. Ooh, I get negative 60. So negative 60. You might have been smarter than me. But basically, that's decreasing. So what do? At this test point, I draw an arrow going down. All right, let's do another one. F prime of negative 1 is going to be equal to, I'm just going to cheat today and do it all again in my calculator, mostly because I'm just lazy. Negative 1, negative 1. Oh, we got 12. Okay, so that's equal to 12. That's positive. So what do I do up here? If it's positive, it's increasing. All right, then we're going to test 1. Put this down here. I've got 1, 1. I get negative 12, so f prime of 1 is equal to negative 12. Decreasing, we draw an arrow down again. And let's do 3. So I substitute those in. And of course, you can do these by hand, but for the sake of time, 60. So f prime of 3 is equal to 60. All right, so that goes up. So what does that mean? All right, what's happening to our graph here? Well, we know that we are increasing. This graph is increasing from negative 2 up until 0, and then again from 2 to infinity, right? Going off forever then. And this is decreasing where? Well, it's decreasing from negative infinity to negative 2. And then again, from 0 to 2. So we have our relative maximum. Our relative maximum is going to be at 0, comma, whatever 0 is, looks like it's 1. And our relative minimum is going to be at, well, we're going to have two of them, right? We're going to have two of them here. So we're going to have -2 comma, well, I'm going to not cheat, but once again, I'm going to put a -2 to the 4th minus 8 times -2 squared plus 1. So that would be 17? 17, that seems wrong. Ugh, kids, don't listen to me. So I should do this again. I'm going to do it actually with 2, because I'm going to have to do it with 2 anyways. 2 to the 4th minus 8 times 2 is 4. So 8, why did I, oh my gosh. So 32 plus 1. Okay, -15, that seems more accurate. So what was that? My 2 comma -15. And actually, because these are even, this is also going to be -15. I don't know why that was so complicated for me. But anyway, that's our answer. This is it. Where we're increasing, where we're decreasing, our relative maximum and our relative minimum. Okay, should we do one more? I think we just have one more. Just one more. Can you believe it? All right. F of x is equal to x squared minus 4 to the 2/3 power. Well, the first thing we have to do is find f prime of x. So f prime of x is equal to 2/3 times x squared minus 4 to the -1/3 times 2x, which is going to be equal to 4x over 3 the cubed root power of x squared minus 4. Okay, and we need to set this equal to 0 kind of, but actually this denominator can't be equal to 0, right? So I'm just going to set my numerator equal to 0 here. So 4x is equal to 0. And then this, I guess, 3 times the cubed root of x squared minus 4. Well, x squared minus 4, let's draw a line there, x squared minus 4 cannot be 0. So it looks like we're going to have these critical points where? Well, when x is equal to plus or minus 2, right? And here x is equal to 0. So these are going to be our critical points that we're going to test, okay? So again, we're going to do -2, 0, and 2. Okay, so I'm going to test here. I'll do a -4. Here I will test -1. Here I'll test 1. Here I'll test 4. And f prime of -4. And actually, I'm going to show you a trick here. We're going to put this into our calculator just as our, so if I put 4x divided by 3 times x squared minus 4 to the 1/3 power, and you might have a fancier calculator. If I graph this, the graph actually doesn't really mean much to us, although it kind of can. This is the graph of our derivative. It's kind of cute. I'm just going to trace these values here. So f of -4, I get something -2.3295, blah, 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 whatever. F prime of -1, I get, so, oh, I'm sorry, I forgot to write this down. If it's -4, it's negative, it's decreasing, right? -1, I got 0.9244, but that's increasing, okay? And then if I test 1, I get negative f prime of 1. I got negative 0.9244, blah, blah, blah. That's decreasing. And if I check 4, I get f prime of 4. I got 2.3295, blah, 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 blah. That's increasing, okay? So it looks like we are increasing. Did I freeze up here? Okay. Increasing from -2 to 0, and then again from 2 to infinity, and I'm decreasing from -infinity to -2, and then again from 0 to 2. And where are my relative minimum and maximum? So it looks like I'm going to have a maximum and a minimum. Well, my minimum is going to be at -2 and 2. And if I put that in, this again, I'm just going to go put this in my calculator because, frankly, I just don't want to have to deal with it. X squared minus 4 to the 2/3 power. So I'm graphing. Ooh, this is kind of cool. Nice little W there. So if I trace, I wanted to trace -2. So my relative minimum. Yes, my relative minimum, I'm going to have -2, 0. Right, -2, 0. And if I trace 2, I'm going to have 2, 0. So I have 2 relative minimums. And my maximum is at 0. So I had maximum at 0, 2.5198. And actually, if you wanted to, you could calculate what all of this is as our actual numbers here. And I think in this case, it's supposed to be 2 times the cubed root of 2 or something. Anyway, I just didn't really feel like doing it, but I know that you know how to do the algebra because you're super smart. Hopefully you are having a great day and you understand this first derivative test. We're doing second derivative test next. Okay, talk to you soon. Bye.